Hello everyone, welcome to my YouTube channel. Let's start with chapter 2, which is related to filtering in Python. In this chapter, I'm going to explain how to do filtering on different data types. I already explained in chapter 1 different data types in Python, so I recommend to go over the topics in chapter 1 in order to understand the topics in this chapter. So I already launched the script of chapter 2. As I explained in the first cell of script, I just import some libraries, those libraries to do for some data analysis and some functionality in Python. I read also the input data. I already post my input data in my channel. So we have an Excel file for input and one access database. So I read the different tabs of Excel file. We have retailers, warehouse items, purchase orders, and customer orders tabs. I already read them. So to start with filtering, I start with customer order 23 data frame, which is this data frame. So I already print the data frame here. Now I want to explain how to do filtering. By filtering, I mean the type of filtering that you do in Excel file. For example, here you want to filter on order quantity and say order quantity, for example, is greater than 300. Then you focus on rows where order quantity is greater than 300. Or you want to do filtering on dates, for example, order date. You want to say order date before a specific date, for example, before 4th of February. Then you focus on records where order date is before 4th of February. So by filtering, I mean this type of filtering that you do in Excel. Now I want to explain how to do this kind of filtering in Python. So as you see, we perform filtering on columns, and we know every column has a specific data type. So I want to point here that to perform the filtering, we first need to know the data type of the column that we want to filter on. The syntax of filtering on float and integer is different from syntax of filtering on dates, and is different from filtering on null values. So in this slide, I want to explain how to do filtering on float and integers. Next, I explain how to do filtering on string or text values, how to do filtering on Boolean, how to do filtering on null values, filter on dates, and finally how to do multiple filtering. And I explain these type of filtering again through examples in Python script. So let's start with filtering on float and integers. To perform filter on floats or integers, let's suppose that we have a data frame with name df, and in that data frame we have a column with name column name, and that column has data with type floats or integers. Here you can see different type of filtering that we can perform on that data frame. In first case, we want to filter on values which are equal to a specific quantity. And in second case, we want to filter on values where they are not equal to a specific quantity. In third case, we want to filter on values greater than or equal to a specific quantity, less than or equal to a specific quantity, greater than a specific quantity, and less than a specific quantity. So be careful about these inequalities. When we have greater than or equal to a specific quantity, it means that quantity is included in those records. And when we have greater than, means that quantity is not included in the resulting records. And we have the same with less than equal to and less than quantity. And here we want to filter on column name, where that column name is equal to some specific quantities. So in the first case, we want to filter on values where they are equal to a specific quantity. In this case, we want to filter on values where they are equal to some specific quantities. So we want to filter on records where the values on those records is equal to quantity 1 or quantity 2 or quantity 3 or quantity 4. And in the last case, you want to filter on values which are not equal to these quantities. So be careful about this negation symbol here. And here we have data frame 1. Data frame 1 actually is the resulting data frame. I mean, the result of filtering is stored in data frame 1. So here I explain the syntaxing on filtering with float and integers. I try to explain these syntaxing through examples in my Python script. So let's go to Python script of chapter 2. As I explained, the first cell, I import some libraries. In the second cell, I read different tabs in our input data. As I explained, this input data is related to our case study, which is a supply chain problem. I read different tabs and store them in a different data frame. And here I want to focus on customer order line 2023. I mean this tab that shows customer order lines in 2023. For example, this line shows this retail number, about this item. This is the order date. We could meet that customer order line, and the size of line is 444 pieces. So we store that tab in customer or 23 underline data frame. It's the name of data frame. And I want to explain how to implement this kind of filtering in that data frame. So I already printed data frame here. You can see the data frame. As I explained, when the data frame is a bit long, you can see only the first 5 rows and the last 5 rows. And in between, you just can see some dots. And here are column names. So if you want to see different data type in one data frame, you can use .info function. I mean, if you write the data frame name and .info, you can see some information related to that data frame. The information like a column name, the number of non-null values in that column, and the type of data in that column. For example, order ID is one of the columns. We have 2000 non-null values in that column, and the type of data in that column is integer. Retailer number, we have also 2000 non-null values, and the type of data in that column is integer. Item number, the same. Order date, we have 2000 non-null values, and the type of data is date. So it's a date time format. In the column meet and miss, we have 1998 non-null values. It means we have 2 rows with null values, and the type of data is object. Object actually is a string or text. When I say object or text and a string, I mean the same. And sales quantity, we have 1998 non-null values. That means again 2 rows are missing, and the type of data is float. So if you go to sales quantity, as you see, and there is 2 miss rows. And if I filter, for example, on blank here, I see 2 rows have missing value. In meet and miss also we see 2 rows are missing. So that's why you see here 1998. And we can see how much this data frame takes from our memory, which is in this case 93.9 kilobyte. And this memory depends on number of rows, number of columns, and data type that we have in different columns. Here you can see the total number of entries. Entries means rows or records in the data frame, and here is the range of index. Indexing always starts from 0 in Python. So we have 0 as the first index, then 1, 2, 3, etc. So here we have index range from 0 until 1999, and that means we have 2000 rows. So data frame.info shows general information about a data frame. So let's start with example about filtering. I mean, I want to explain this syntax by examples. And the first example, I want to say how to find customer order lines where order size is less than 230. So here I use the data frame name. Here's the column name where I want to do filtering, and here's the quantity that I want to filtering on. So in this case, I show the records where sales quantity is less than 230. So if you look at the sales quantity here, in all records, you see the quantity less than 230. And in Excel, I want to explain how to store the result of filtering in a new data frame. So here I use the same filtering. I mean, I filter on sales quantity less than 230, but I store the result of this filtering in a new data frame, and I call it customer order less than 230. So it's a new data frame. If I printed the data frame, you see this data frame is the same as here. So here I just show the result of filtering, no new data frame. And here I store the result of this filtering in a new data frame. So from this line onward, I have a new data frame that shows sales quantities less than 230. And I want to show you a trick. Here you can see only the first 5 rows and last 5 rows, but to see the all rows in a data frame, you can use XW view and put here the data frame. Then you can see data frame in a Excel sheet. So in this Excel sheet that shows the customer order less than 230, I should see sales quantity less than 230 because I store them in a new data frame. So if I filter on sales quantity, you see sales quantity is less than 230. You see? So it means the filtering works properly. So let's go to the next example. In the next example, I want to filter on sales quantity exactly equal to 230. I mean, these kind of filtering. So I want to filter on column name that is exactly equal to a specific quantity. So it's this example. And I want to store the result to a new data frame that is cost or equal to 230. As you see, the sales quantity in new data frame is equal to exactly 230. In next example, I want to filter on sales quantity greater than 670. As you see, there is no rows where sales quantity is greater than 670. If I go to input data and I look at the sales quantity, I see the maximum sales quantity is 500. So this filtering also works properly. So if you don't see any record, means there is no records in that data frame and that data frame is empty. And in the next example, I want to filter on sales quantity, which is not equal to 280. And I store the result of data frame to a new data frame, and I call it cost or not 280. So if you look at the sales quantity in this column, none of sales quantity is equal to 280. So I use this filtering. Again, I can see the result of a data frame in an Excel sheet. If I put here XW view, and I see them in Excel file, so I should not see 280. You see, I have 279 and I have 281, so there is no 280. So in this case, the filtering works properly as well. And in next example, I want to filter on sales quantity, which is equal to one of these three quantities. So, and I want to store them in new data frame. I call it cost or sum quantity. As you see in the sales quantity, I have only these three quantities. So I mean 245, 134, and 98. So you understand how this filtering works. So again, this filtering means show me the records where sales quantity is one of these three values. So actually I'm using this kind of filtering. And in last example, I want to show records where sales quantity is not equal to these quantities. So be careful again about this negation symbol here. So if you see the sales quantity here, there is no records where sales quantity is equal to one of these values. Again, you can print the result of data frame to a Excel sheet. Let's say XW view. So here in sales quantity column, I should not see any of these quantities. 98, 134. Let's see. Here I don't see 98. No 98. 134. I don't see here 134. The other one 245 and 456. 245. I don't see 245. Another one 456. I don't see 456. Let's see. No 456. So it means the filtering works properly. So I explained this syntaxing by example to Python script. Next, I want to explain how to do filtering on the string variables. So let's suppose that we have data frame df, and in that data frame we have a column name, and that column has a data of type string. And here you can see different type of filtering that we can do on that string column. Here I provide the syntaxing and one note. So I try to explain this syntaxing through examples. So let's go to the Python script. Here I use purchase order lines of 2023, which is in this tab, and this data shows purchase order lines from supplier. For example, this line shows we bought this item from this supplier. It is the order date, it is the promised delivery date, it is the status of that purchase order, that's the lead time, it's the arrive date of that purchase order, and it is the order quantity. And here I want to explain how to do filtering on string columns. First, I use info function. By info function, as I explained, you can see the general information about the data frame. Here are column names, the number of non-null values in each column, and data type. So here I want to focus on column status that has data type of object. So in first example, I want to filter on purchase order of 2023, and I want to filter on status, which is equal to cancel. So the result of this filtering shows records where the status is only cancelled. So as you see in the resulting data frame, the status is equal to cancel. And in next example, I want to filter on status is not equal to dispatch. And I want to print a result of filtering on a new data frame, and I call it not yet dispatch purchase orders. So as you see in the status column, I cannot see dispatch. And in next example, I want to see records where status is equal to cancel or dispatch. And again, I want to print them in new data frame. As you see in the new data frame, the status is equal to cancel or dispatch, cancel or dispatch. Okay. And one more example. In this case, I want to read suppliers table from Access database. It is another input data that we have. I already explained how to read Access database in chapter 1. Please go over that chapter and see how I read Access databases. So in this case, I read suppliers table and I call them suppliers data frame. If I use .info function for supplier data frame, you see the country has a data type object, and I want to focus on a country column, and I see how to do filtering in this column. And let's see this table also in Access database. So it is the suppliers table, and I want to do some filtering on country column. Okay, so in first case, I want to do filtering on country, and I want to say, show me the records where country is USA or Germany. So here we have country, USA, I mean this record, that one, Germany, USA, USA, Germany. So I want to see only these records. So it's the type of filtering that we need to use. So as you see in the resulting data frame, the country is either USA or Germany. And in second example, I want to see records where country is not equal to one of these string values. So again, be careful about this negation. This negation actually make this criteria negative. So here we say country is one of these one, and when I say negation, it means country should not be equal to one of these values. So again, if you see the country column, you cannot see UK, DM, IT, or NL in country code. Okay. And next example, I want to explain how to compare strings. So here I want to say in supplier data frame, filter on cities where city is greater than n. So maybe somebody asks, what does that mean city is greater than n? Here I want to explain how to compare a string. And here I want to explain the order of strings. First, please note that when I use double quotation, I mean the text format of that value, not the numerical value of the that term. For example, here I use double quotations for 0, 1, and 2. So I mean the text format of 0, 1, and 2, not the numerical format of 0, 1, and 2. And here you can see the order of string values, and that order means any text that starts with 0 is less than any text that starts with 1, and any text that starts with 1 is less than any text that starts with 2. Here is one example. Here 0 RT is less than 1 RT because the first one starts with 0 and this one starts with 1. So 0 is less than 1 based on this order. So this string is less than this string. 1 RT is less than R A Y Y because this string starts with 1 and this one starts with R, and based on this ordering, 1 is less than R, so this string is less than this string. In this case, both strings start with R, so we cannot compare them. In this case, that we have toy, I mean the first term start with R, so we look at the second term, which is A, and in this case is T. Based on this ordering, A is less than T, so this string is less than this string. And RTU is less than ZUY because R is less than Z based on this ordering. So it's the way to compare the string values. So let's back to our example. In this example, we look at the suppliers data frame, and I want to see cities where city is greater than N. So if we look at the suppliers data frame and we sort them from A to Z, so all of these values are less than N. So from here onward, we see the string values, I mean the city values that are greater than N. So we should see those one as a resulting data frame. So as you see in city, all these string values are greater than N. So here also I provide one example about this type of filtering. So if you back here, so we can use this kind of syntaxing for filtering. For example, here in this case, I use this type of filtering. Okay, the last one. Here in this example, I use this kind of filtering. Okay, and in this case, status is not equal to dispatched. I use this case. Okay, and in last example here, that cities is greater than N, I use this case. Okay, so we cover filtering on a string. Let's go to the next topic, which is filtering on Boolean. As I explained in chapter 1, Boolean are the type of variable that takes only two outputs, true or false, yes or no, missed, unmissed, false or true. So I want to explain how to do filtering on Boolean variables. So here we have this kind of syntaxing. They are very simple. So in data frame df with column name, I want to filter on values that are true. In this case, I want to filter on values that are not true. Here I filter on values that are false, and here I filter on values that are not false. So I need to mention here that this filtering that variables are true is equivalent with variables that are not false. When variables are not false, it means they are true. So the first and fourth one are equivalent, and the second one and third one are equivalent. And let's go to example. So here I want to explain filtering on Boolean. I use again suppliers data frame, which is a suppliers data frame in Access database. I already read that table here. You can see the information of that data frame. And now I want to focus on manufacturer, which is in Boolean format. As I explained, .info function shows the information related to data frame, the column names, the number of non-null values, and the type of data in each column. So manufacturer, as you see, it is in Boolean format. Here, first, let me explain something about the formatting. Some data type has different names. For example, when I say Boolean or bool or binary or yes and no or true and false, I mean they are the same. When I say a string, text or object, I mean the same. And when I say integer, float or numbers, I mean they are the same. So let's go to suppliers data frame. I want to filter on records where the supplier is manufactured, as I explained in suppliers table. So we have one column that shows that supplier is manufactured or not. And to see the data type of Access database, here you can see the data type. For example, supplier is called text. All of these files are text. Manufacturing is yes and no. You see in Access database, the type of Boolean is shown as yes and no instead of Boolean. So I want to filter on suppliers where they are manufacturing. So here I can filter on those suppliers. As you see, it shows the records where the supplier is manufactured. And the second example, I want to filter on suppliers which are not manufacturing. Manufacturing is false, that it shows the suppliers that are not manufactured. Okay, that's very simple. just two examples. We can cover the next topic, which is filtering on null values. As you know, null values mean empty rows. So I want to explain how to filter on empty rows, how to exclude them, or how to filter on null values. So let's focus on purchase order 2023 data frame that I read already from Excel file. Is purchase order line 2023, which is here, and I want to filter on order date. I want to see which rows order date is null. So it's the way to filter on null values. Let's first see the syntaxing. So syntaxing is very simple. I want to filter on null values and I want to filter on non-null values. And I want to explain one note here. Null values in Python for a string and numbers are shown as NaN, it means not a number. And for variables with type of date are shown as NAT, not a time. Okay, so if in any record of a data frame you see NAT, it means that column is in date format. It means it's not a time. See, here you see not a time. So here I want to filter on purchase order line and filter on order date, and I just want to show order dates that are null. It means I want to show records where order date is not mentioned or order date is empty. Let's go to order date. So here in Excel file we have blank, so I want to show these two rows where order date is not filled. Again, by null value I mean empty rows. So if I here mention okay, report records where order date is null, then you will see that two records. You see, it's the same as these two records here. And next I want to say filter on records where status is null. So let's clear this filtering, and I want to filter on cases where status is null. So I see 4 records. So status is null. As you see, it shows not a number or not a value. And I want to filter on cases where status is not null. So it means all data frame except these 4 rows. You see here, you see the index of the rows. So here I should not see these indexes. As you see, we have index 0, 2. So 1 is not there. 3, 4, 5 is not there. So status not null means filter on cases where status is filled. So I can say all rows except blank. It means exclude these rows from all data frame which result to this data frame here. And next topic is filtering on dates. Filtering on dates is a bit tricky. So let's see how to do filtering on dates. To perform filtering on dates, we need to define first a timestamp. Timestamp is a specific point in time. To define a timestamp in Python, we can use this function where we can define the time in this format. I mean month, day, year, month in 2 digits, day in 2 digits, and year in 4 digits. And TS is the variable that we store that time stamp. And here is the different type of filtering with time. So in the first case, we can filter on a specific timestamp. In second case, we can say date is not equal to a specific timestamp. And here we can say dates are after a specific timestamp, and here before a specific timestamp. So in these inequalities, the first two, that timestamp is included, and the last two, that timestamp is not included. So here's the syntaxing. Let's go to example to see how do filtering on dates. Again, I focus on purchase order lines table, which is this tab in Excel input, and I can perform filtering on dates. And as you see, order date, promise delivery date, and arrive date are in date format. So date time 64 is the date format in Python. So here we have 3 columns where we can perform filtering on dates. So let's go to the first example. In the first example, I want to list purchase orders with arrive date later than 26th of November 2023. And it means 27th of November and after that. Okay, so we first define the timestamp, which is 27th of November 2023, and we store that timestamp in variable and we call it TS. And here we say in purchase order line, show the records where arrive date is after TS. And what is TS? TS is this date, which is 27th of November 2023. And we store the resulting data frame to a new data frame, and we call it purchase order arrive December. So if you print the data frame in an Excel sheet, as I explained previously, you can see the resulting data frame also in Excel sheet. So if I focus on arrive date and I sort them from oldest to newest, you see all arrive date is after 27th of November. See 27th of November, 28, 29, and 30. So it means that the filtering works properly. Let's go to the second example. Here I want to list purchase orders with arrive date on 23rd of October 2023. It means show the records where arrive date is exactly 23rd of October 2023. So I define timestamp here, and I store that timestamp in TS1. And here I say in purchase order 2023, arrive date is equal to timestamp 1. And timestamp 1 is 23rd of October 2023. And I store the resulting data frame to this data frame, and I print data frame here. As you see, the arrive date in this case is exactly 23rd of October 2023. And if I go to this table and I filter on arrive date, and if I look at October 23, you see I see only 3 records, and these 3 records are the same as these 3 records here. So this filtering also works properly. And the other example, I want to list purchase orders that are ordered before 16th of March 2023. So here I define the timestamp, which is 16th of March 2023, and I store that timestamp in TS3. And here I do the filtering in purchase order line data frame. Order date is before 16th of March 2023. So this timestamp 3 is the same as this, and here we define that date. So again, we store the resulting data frame in this data frame, and if I print it here and also in Excel sheet, so we should have order date before 16th of March. So let's focus on order date. As you see, order date is before 16th of March. So we have 15th of March, 14, 13, 12, 10, etc. So this filtering also works properly. Okay. And in next topic, I want to explain how to do dynamic condition on dates. So in previous example, I define a specific timestamp and explain how to do filtering on a specific timestamp. In next example, I want to explain how to do dynamic filtering. For example, sometime I receive a request that show the customer order lines in last 3 months, or show customer order lines in last 20 days. So you need to focus on date of today and look at what is the date in last 20 days and do the filtering based on that. So here I want to explain how to do a dynamic filtering on dates. I provide some examples here to explain dynamic conditioning on dates. So in the first example, I list the purchase orders that are ordered in last 90 days. I mean, date of today minus 90 days. Now I explain how to do this filtering. So in the first step is to get the date of today. This is the function in Python that we can get the date of today. And we store that date in a variable, and I call it today date. Second, we define the time delta, which is 90 days. And again, we call it last 90 days. It's a name of variable. And here we get the date of 90 days ago. And I store that date in date 90 days ago. It's the, again, name of variable. And here I convert that date to a specific format because timestamp should be month, day, year format. So I use this function to bring that date to a specific timestamp format. So be careful. Timestamp should be month, day, year. Okay. So by this step, actually, I bring it to the format that I want. So here you see the date of 90 days ago. So I'm recording this video in Netherlands, and current time and date in Netherlands is 20 February 2024. And here's the date of 90 days ago, which is 22nd of November 2023. So we get the date of 90 days ago, and we use that date to define timestamp 1 and use timestamp 1 for filtering. So we use pt to datetime function to convert that time to the timestamp, and we use that timestamp for filtering. So here we say show the records in purchase order line data frame where order date is less than timestamp 1, which is 22nd of November 2023, and it is the resulting data frame. If we print the resulting data frame in Excel sheet, we should see order date before 22nd of November. So here we see all order date is before 22nd of November. So it means the filtering works properly. And we can go to the second example. In the second example, we want to list the purchase orders that arrive date is after today. So it's very easy. Again, we get the date of today and we store in variable today date, and we bring that date to the specific format, which is the format of timestamp, as we explained here. And we define it date of today. So date of today is 20th of February 2024. Again, we use that date to define timestamp 2, and we do the filtering. So here we filter on purchase order line data frame, and we filter on arrive date after 20th of February 2024. And again, if I print the resulting data frame, here if I print the resulting data frame, we should see arrive date after 20th of February. So arrive date is after 20th of February. See, all of these days after 20th of February 2024. So again, filtering works properly. And third example. So before going to the third example, I want to explain some function related to the time in Python. So we can print the date of today, year of today, month of today, date, hour, minute, and second of timestamp that we are currently in. Okay, so here is the date of today, year of today. I mean, I print these function one by one, and here you can see the result of each function. So the first one is date of today, second one this year, here current month, which is February, current day is 20, current hour is 8 in the night, minutes is 6, and second is 15 seconds. Okay, if I run it again, you will see at least hour and minutes will change. And I want to use this function to explain the third example. In the third example, I want to list purchase orders that have promised delivery date from beginning of the current month till today. So how to get the date of current month? So to get the date of current month, I mean the first day of the month, we need to know what's the current month and what's the current year. So we can use this function to define our time stamp. So I want to define a timestamp. I call it timestamp 3. And I want to get the current month, the first day of the month, and current year. Again, be careful. We should have month, day, year, because the format of timestamp is month, day, year. That's why I bring month first, then day, which is first of the month, and then year. So I define here timestamp 3. So as you see, it is 1st of February. Currently, we are in February 2024, and I get 1st of February 2024. And here I can do the filtering. So in purchase orders 2024, I filter on promised delivery date after 2nd of February. And here is the result. Again, we can print the resulting data frame, XW view. So you will see promised delivery date is after 1st of February, 2nd of February, 3rd of February, and etc. So again, filtering works properly. And next topic is multiple filtering. So let's see syntaxing for multiple filtering. to perform multiple filtering in Python, we can have different conditions and we can use different operators. For example, in this case, I'm using two conditions and I'm using an operator, and that filtering means both condition 1 and condition 2 should hold at the same time to see the resulting data frame. And or condition means either of these conditions should hold. And you can use a combination of and or condition like these cases. So here is the syntaxing, and I want to explain this syntaxing again through examples. So let's go through examples here. In the first example, I want to list purchase order lines where status is null or order number is 7056. So here I write down condition 1, which status is null, and here I write down condition 2, which shows item number is in 7056. So in the resulting data frame, you see records where either status is null or item number is 7056. So if you look at the rows, item number is not 7056, so status is null. So as you see, one of these condition holds. In this case, again, item number is not 7056, but status is null. In this case, status is null. Here, status is not null, but item number is 7056. So as you see, we report records where either of these condition holds because we are using or condition. And one thing that most probably you notice is that here we can have condition from different type. Here a conditional null and here a conditional string. So you can have multiple conditioning in different formatting. Here is condition on a string and here is condition on null values. Okay. So in the second example, I want to condition on a specific time window. I think here I explain the syntax in here. I want to explain through example. So here I define one timestamp 1, which is 15th of May 2023, and timestamp 2 is 29th of January 2024. And here I want to report records where arrive date is after 15th of May and before 19th of January 2024. So I'm filtering on a specific time window. So multiple filtering helps you to filter on a specific time window whenever you are working on a data with date format. So if I print the data frame, let's say in Excel sheet again, exterminate you. So let's look at arrive date here. So arrive date should be after 15th of May 2023. You see, it's after 15th of May 2023. We have June here, and it should be before 29th of January, and it is before 29th of January. See, 29th of January is included because we have less than equal. And last example, I want to list purchase order lines with lead time greater than 3, which are delivered with arrive date after 26th of October 2024. So we have 3 conditions. First condition, lead time greater than 3. As you see, I put condition in parentheses. These parentheses are very important. If you don't put these parentheses, and then this filtering doesn't work. So the next condition is status is delivered. Again, I put it in parentheses. And arrive date is after timestamp 1. Timestamp 1 is defined here 26th of October 2024. So in the resulting data frame, we show records where these 3 conditions hold at the same time. So condition 1 says lead time should be greater than 3. As you see in the resulting data frame, lead time is greater than 3. And be careful about this one. Here we have a greater than 3. We don't have greater than or equal to 3. So that's why 3 is not in this column. And the second condition says status is delivered. As you see, all the status are delivered. And the third condition says arrive date is after timestamp 1, and timestamp 1 is 26th of October 2024. As you see, arrive date is after 26th of October 2024. So as you see, these three conditions hold at the same time in the resulting data frame. So let's back to syntaxing again. Here I want to mention two important notes again. One, don't forget to put parentheses for your condition. If you forget to put parentheses for your condition, then the filtering doesn't work properly. And be careful about and or condition. I already explained what's the difference between these two operators. And lastly, I want to explain one note. It's about or condition. Let's say I want to filter on a column with column name, and I want to say that column name should be equal to a string 1 or a string 2 or a string 3. So it's one method to use or operation to say column name is equal to a string 1 or column name is equal to a string 2 or column name is equal to a string 3. Or in another method, you can use this syntaxing that has the same meaning and say column name is equal to one of these three string values. So these two syntaxing are equivalent. So but I can say the second one is a smarter way compared to the first one. So that's the end of chapter 2. Please don't forget to subscribe my channel. See you on chapter 3.